Hey, I'm Corey Goebel, and my presentation today as we transition from teacher beliefs to teacher decision making hopes to provide a cognitive perspective on why teachers do what they do in the classroom. So to start, Pajares, 1992, identified that teacher beliefs and practices are definitely separate constructs. So even if a teacher believes in a particular research-based approach, it doesn't necessarily mean it's going to translate to practice. So research related to teacher beliefs and decision makings need to consider this anomaly. In the context of science education, Mansour, 2013, indicated that oftentimes teachers have positive beliefs about student-centered science instruction, things that align with science education reform. But those beliefs often fail to translate to practice for some reason. Even if they hold these student-centered views, they often teach in a traditional manner upon observation. This was a finding as well from America's Lab Report. That was actually 2005. In America's Lab Report, the report was that science teachers use the lab a lot. Science teachers hold the laboratory as an essential aspect of all science curricula. However, the way that the lab is used is largely disconnected from the goals of science education reform. So teachers are erroneously thinking that they're implementing inquiry instruction, but it really doesn't translate into what is meant by inquiry instruction according to reform-based practice. So in other words, hands-on doesn't necessarily guarantee that things will be student-driven. The next generation science standards advocate inquiry-based laboratory investigations. So instead, oftentimes science teachers use the lab as a verification mechanism. Sometimes it's even disconnected from the instructional sequence. So what's referred to sometimes as a cookbook style is ineffective at fostering scientific practices, a central tenet of the NGSS. So students aren't just verifying content, they should be designing their own experiments and problematizing, which does not occur when things are heavily prescribed. So science teachers advocate and believe in inquiry instruction, but they usually don't implement it into practice. So that brings up a couple of questions and sort of the impetus of this presentation. So how can this disconnect be ameliorated? And what barriers presently exist? So I wanted to, before we get into the cognitive details, I wanted to provide a quick video of a mental representation.
Cognitive psychologists suggest that we use mental representations to represent our knowledge, memories, or ideas in order to store and maintain our mental processes. Mental representation is defined as a structure in our mind, such as an idea or image, that stands for something else, such as an external object or things that we sensed in our past or future. But whatever it is, it's not something in the present. These mental representations allow us to think about things that are abstract and have no physical existence. Earlier in this lesson, when we talked about language, we asked about love and passion. We can also include things such as truth or justice as abstract ideas that we can represent in our mind visually and verbally.
Okay, so mental representations. Science teachers, their instructional decisions are based on a confluence of mental representations. So a variety of different ways that they view the world around them, what they think instruction is supposed to be. According to Markman and Diedrich, representations are a type of mediating state that allows for information processing between an individual and their environment. So it's still pretty obscure, but in my mind, I like to think about say a dog. Everybody has this mental representation of what a dog is supposed to be. And even though in their minds they've got this quintessential example of a dog, of course, they can encounter examples on a daily basis that don't quite align perfectly with what's in their mind, but they still recognize it as being a dog. And from a stance of student learning, students have these maybe undeveloped representations of things that can be built upon as these schemata increase in complexity. So I wanted to pause for interaction for a second. And we don't have time in this particular video to spend a lot with the video paused, but I want y'all guys to pause the video on your own and consider the following questions. So we all hold mental representations about teaching and learning. So like I was talking about, these are embedded as sort of stock, quintessential examples of what it means to be a teacher, what students are, what the instruction is supposed to look like, whether they're inaccurate or accurate. And these representations, they influence the instructional decisions that are made in the classroom. So the focus article for this presentation is Huttner and Markman, 2017. And what we just identified a second ago was exactly what drove their study. Science teachers are quick to discard the pedagogy and practices that they learn in their teacher education programs in favor of a traditional didactic approach. And there's a discrepancy at all stages of science teachers' careers between their pedagogical preferences reflected in their self-reports and the behavior that they actually exhibit during classroom observations. So why is it that teachers make the particular decisions that they do in the classroom, and oftentimes those decisions be disconnected from what they actually believe to be best practice? So Huttner and Markman broke down these representations into three major categories that influence a science teacher's beliefs: environmental, mediating, and goal representations. Environmental representations being those things that are contextually related, things that influence what types of immediate environmental sensory issues that they've got going on, like student behavior perhaps, the arrangement of the classroom, the availability of particular resources, for example. The schedule itself is going to influence the way that you're able to do the things in the classroom. So those environmental representations are a pretty big deal that we'll come back to in a minute. Mediating representations would be things like pedagogical and content knowledge or beliefs about instruction, the content itself, student ability. So those types of things are also going to be involved in why teachers do what they do and the decisions that they make. But ultimately, these things are sort of subordinate to goal representations. A goal being a particular vision that the teacher has for what they want to get out of a lesson. It could be applying inquiry instruction or the Alabama Course of Study standards, perhaps. Or maybe they have broader goals like fostering student interest in STEM. But according to Huttner and Markman, so the activation of a particular goal representation activates mediating representations and environmental representations related to that goal representation. So here's a quote: "The particular goals that a science teacher is thinking about when preparing a lesson affects the value given to the various instructional approaches they know about, and ultimately the choice to use a particular instructional approach. So the confluence of these representations ultimately drive what decisions teachers make in the classroom. Those decisions may end up being for or against their ultimate goal representation at the end." So this was the graphic that was used in the Huttner and Markman article. You've got these three categories of representations ultimately leading to teacher action. So an illustrative example. Let's say that a teacher, myself in this example, holds that 75% of students should make a B or better on an ecology unit exam that has information about water cycles and the carbon cycle. So that's my personal goal representation in this case. That is going to then activate mediating representations, like my own knowledge of how to conduct a lab activity about plant transpiration that I learned in a professional development. And those decisions are still going to be influenced by environmental representations, like the time available to do these things. For example, this activity that I want to do may take at least 3 hours, and class periods are 45 minutes. Laboratory material availability. Do I have the materials to actually carry out this thing in my mind? So the goal representation was the impetus for the activation of the other representations that directly influence the instructional practice. So if the Alabama Course of Study Science are to result in actionable change that can meet student needs, They have to be accompanied by teacher training that also activates those goal representations that are congruent with the goals of science education reform, and this is the most important part, they're relevant to a teacher's instructional context. So, what forces work against effective decision making? We're going to cycle back to that in just a moment. So, in cognitive science, there's a recognition of two systems of processing, mental processing, System 1 and System 2. So, Evans, 2008, took this concept and looked at, I guess, sort of a meta-analysis of a variety of studies and sort of summarized System 1 and 2 as System 1 being automatic, unconscious, fast, intuitive type thought process. System 2, on the other hand, are more controlled, rational, slow, analytic. So for novice teachers or emerging teachers, complex cognitive tasks such as facilitating discussions, recognizing and addressing student misconceptions, and managing student behavior are all dealt with through System 2 processes. They take much more cognitive effort and focus. So inquiry-based instructional decisions are going to fall into that System 2 category. Evans supports the notion that repeated use or activation of System 2 processes can result in automation. So in that sense, System 2 processes over time can become System 1 processes, reducing cognitive load on future uses of the System 2 processing in similar contexts. So this is supported by other studies of cognitive science. You've got National Research Council's How Students Learn 1, indicating expert knowledge is conditionalized. So experts are able to chunk by recognizing meaningful patterns. They're able to better and more quickly retrieve information according to a particular context. And effective decision making is developed within authentic experiences. So in the real environment in which those types of decisions are needing to be made. So concerning teacher training, if there's a mismatch between learning environments and actual teaching context, that may explain why transfer often does not occur. And that's supported by How Students Learn 2 by the National Academy of Sciences. So teacher training and the things that teachers go through as far as how they were originally learning in their initial certification process or through professional development as an in-service teacher, those types of things are going to be, they need to be highly contextualized for it to actually result in transfer. Otherwise, those decisions that they make in the classroom might fall to more traditional styles. So applying Hunter and Markman to decision making, you've got this variety of environmental and mediating representations that function as barriers to effective decision making, and they work against the actualization of those goal representations. So let's pause for interaction again. If y'all guys want to pause your screens here in just a moment, I want you to identify at least 3 environmental representations that affect the types of decisions that you make in your own classroom. So what are some of the environmental representations that affect your own decision makings in a given moment? And then how do those work for or against your ability to realize the goals that you have for your students and yourself? Okay. So I identified a few representations that I think that are involved in any given classroom, especially a science classroom, and how those particular representations differentially draw from your System 2 processing. So comparing expert teachers to novice teachers become bogged down through the environmental and mediating representations in their environment that take away from their cognitive capacity. So things like facilitating discussions or knowing students, behavioral management, addressing and identifying misconceptions. So all of those are really taking away from the teacher's ability to effectively teach and make good decisions. On the other hand, expert teachers who have become conditionalized to these types of things, not all, but some of these elements can kind of be passed on to their System 1 processes through repeated mental mapping. Things like timing of lessons, content knowledge, knowledge of their students, how to deal with instructional disruptions, and material management. Those types of things become more fluid over time, but still some things are going to require a lot of mental focus. And they've got more to give in this case to things like identifying and addressing misconceptions or facilitating effective discussion. So this was a graphic that I created that it may be common sense, but sometimes it helps to see these things. So in summary, according to Felden, 2007, is a claim that most research focusing on teacher beliefs has been largely unfruitful since they have not fully considered teacher cognition. So teachers may make decisions that they acknowledge as not in keeping with best practices. And the question here in this presentation is why? And that could fall to a failure to consider the cognitive aspects in this case. So these cognitive perspectives can help explain why teachers may hold certain beliefs about instruction, but those beliefs not manifest into practice and effective decision making. So drawing from a dual process understanding, expert teachers have more experience performing within the modern classroom context with all its myriad extraneous challenges that detract from teaching and learning process, primarily those environmental representations. From classroom management to administrative and bureaucratic responsibilities, novice teachers' working memory becomes bogged down, reducing their likelihood of making effective decisions in keeping with what they believe is research-based practice. Repeated mental mapping of stimuli is thought to help experienced teachers develop more elaborate schemata. Then those highly developed and contextualized schemata function to shift mental effort away from extraneous factors and toward those associated with effective instruction in real time. For novice teachers, intent to teach and beliefs about teaching unfortunately take back burner in lieu of more familiar traditional instructional methods when mentally taxed. So the default is to go back to maybe the way that you were taught, the things that are familiar to you, things that seem easier. So teacher education programs and in-service professional development should seek to design learning experiences for teachers that support minimizing cognitive load through the provision of authentic learning tasks presented at varying levels of complexity. For in-service professional development, these should be further providing learning experiences that are highly contextualized, things that are clearly and demonstrably connected to the same goals that are activated within a teacher's actual practice. And I'm not sure about your own experiences, but for mine, there's always going to be a tangential connection to your classroom context. But without having the actual students that you're going to have, without actually having the exact same content that you're going to teach, professional development is going to be limited in its ability to actually hit the same context, helping to build those those schemata for addressing particular things in real time in the context that you're going to have in your own classroom. Without that, transfer might be less likely. Here are the references that I used for this particular presentation, and I hope that this lesson has provided some valuable takeaways for anyone watching it. Thanks for listening.